Hello friends, and welcome back to part 3 of the Mole Shooter game programming tutorial that I have created just for you. Today we are going to cover, as promised, our friend Michael the Mole. This little fella that you see down here on the screen. We're going to be going and discussing the process of obtaining him, which, to be quite honest with you, isn't very difficult. Editing him, and then placing him within the application, and then obviously getting him ultimately onto the screen. So a quick quick search on Tinternet provides us with the following graphics, or more to the point, a quick search on Cartoon Mole provides the following graphics. And as you can see, this little fella here looks very familiar. You can also obviously click images and see what we get, and voila. Now a lot of these are stock photographs which you obviously have to pay to obtain. However, this little friend here, which is the guy that we're using within our games, appears to be a freebie. So I essentially went to this guy's site, found him, then we had a little look down here to see what we can see with regards to formats. We've got a PNG, a TPNG, a SVG, a WebPG, BTGC, and a JPEG. So I took the PNG because it's scalable, and we downloaded that to our desktop. So once you've downloaded your image, load it up inside a paint editing program such as Photoshop. The objective of this exercise is to remove the background. I do it by using the magic wand in Photoshop, basically selecting this background, press the shift key, select all the white background areas, go to select and inverse selection, select modify selection, and now we want to contract the selection by, let's say, 3 pixels, 2 pixels. Hopefully 2 pixels will be enough. You'll see now that that selection has gone in to the perimeter of Moley. The idea of the of this exercise now is to remove the white and also any potential white fringing which may get left behind on the mole. Otherwise, that will stand out quite obviously, quite obvious inside of the game. So now you do inverse selection again, and then just press delete, and hopefully that will remove all the background. Get rid of your selection. Let's add a background layer now with a new color, black for example, just to test that we've actually removed all the white fringing. You can see we've still got some fringing here, look. So again, select the mole and zoom in as close as you can. Get the delete or eraser key. There you go, get the eraser. Then reduce the size of the eraser, and then you can just go in here like so and touch that up. Okay. You don't want any of the background showing through at this point, otherwise it will spoil the effect in the game. Get rid of as much as you can, and I think that pretty much is it. Once you've done that, get rid of that background layer, you don't want that. Then you just go to File, Save As, and save him back as Mole Cartoon 2. The reason why we're making a backup, obviously, is that we might have to come back and make changes, so don't erase the original mole. It's also worth bearing in mind the size of this guy. He looks quite large here, and we can look at the image and the image size. He's 375 pixels wide by 283 pixels high, which is quite large. We may end up having to reduce him. So close down Photoshop and back to the game. So we need to get the mole into the game. So you do that as previously mentioned when we did the background. You go to your project and you go to Mole Shooter Properties Project, and then you go to Resources, Add Resources, drop that menu down and select Add Existing File. Okay, and in here we want to go to our resources folder, select mol2, save, close that resources tab down. And now you'll see that our friend has appeared over here in the resources palette, mol_cartoon2. We could incidentally rename him, that's quite a long name, so we can go back to mol shooter properties, click on the name, then click again, and just select, just type mol. It's a bit easier to type or to reference later on within the game code. So now all that is left to do is get the guy on the screen. So going back to the painting of this chap, we need to have a little think about how many graphics we're going to put on the screen and how often we're going to be calling similar methods. So as an example, we're going to be painting this bitmap to the screen or drawing this bitmap to the screen. We're also going to be drawing a scoreboard to the screen. We're also going to be drawing the hotspot signpost to the screen. We're going to be drawing the splat to the blood splat to the screen. So there's going to be quite a bit of duplication going on as far as the code is concerned. So I want to try and bring all this code together, all the duplicated code together into a single block of code, and we're going to do that by creating a base class. Okay, so right click your mol project, add class, and we're going to call a class C for class image base. Enter. And you can see that's created a new class. What we're going to do here is overwrite this class with a copy of code that I created in the demo program I showed you in part 1, just to save some time. But I'll go through each part of this now so it's clear to you. Now, obviously we've got some errors here. This is because we've not included the drawing, system drawing references. We can do that quite easily by clicking the bitmap and then hovering over this little flag that appears, clicking and then selecting using system drawing, and you can see now that we've got the references to those installed correctly. So first thing to note here is we've got an IDisposable, so we're using the IDisposable interface. Why are we doing that? Well, IDisposable is part of the .NET architecture. Don't have to worry too much about where it is, other than what it's doing. IDisposable helps us to clean up our objects that we create within our application. So a lot of objects have got the dispose method attached to them. By calling the IDispose, it will release things like bitmaps, bitmap handlers, etc. So what we're doing is we've inherited that, and you can see here now that we are actually using the dispose method, which is derived inside of the IDisposable interface. Okay, so hence the reason why it's a virtual, we're overriding it. And we're basically setting a flag here, dispose true, and that's going to dispose that's going to call this dispose here, which is the public dispose method, which we call from outside of our bitmap class. So for example, inside the main drawing routine, when we finish with this bitmap and we want to dispose of it, we will go bitmap.dispose. That will call this method, which will in turn call dispose. This dispose obviously is the same function name. However, because this one has a parameter and this one doesn't have a parameter, okay, it knows to call this version of the dispose method, which is protected. What protected means is that the method is protected to the point that you can only call it within inside its own class or any derivatives of this class. And we're passing it in a boolean disposing, and down here you'll see that we've got if disposing, i.e. which it is because we set it to true, then bitmap.dispose, so get rid of the bitmap. Okay, and that'll free up some memory. And then we set dispose true. Okay, so that basically means that up here, if disposed is true, which it obviously is, i.e. we've disposed of the bitmap, then return. That basically means get out of here and don't dispose of the bitmap again, obviously because it's not there, and it throw an exception. Okay, it's a little bit wordy, but it's fairly straightforward. If you walk yourself through the code quite slowly and methodically, I think you'll be able to figure out what's going on. Okay, so just to summarize, call dispose. Dispose in turn calls another dispose, passing true, which means we want to dispose the bitmap into this dispose method. If the dispose flag is false, which it is, because when we came into the class or created the object of this class, we set it to false, don't return. Move on to the next if statement. We can see that if disposing is true, which it obviously is, by virtue of the fact we set it to true here, clear up the bitmap, dispose of the bitmap, now set dispose to true because we've obviously gotten rid of the bitmap. This basically means now when you call disposed again, or if you were to call disposed again, it'll come into this method and it'll see that disposed is actually true, so it'll return and not try to dispose of the object again. Okay. Next thing to note is we've got a handle to the bitmap, so when we pass the bitmap object into the base class, that's where it's held. X and Y are the top left coordinates of the bitmap. These are private, essentially implying that you can't actually get access to this X and this Y, so it's protected and it's only accessible from within the class that created them. Just below that you'll see we've got two properties, and these are now public, and we've labeled these left and top. So essentially from outside the application, inside the main form, you can now come into this object and you can say my bitmap.left is equal to 10 for an example, and what that will do, it will assign the value 10 to X, and X is up here. Okay, and the same goes for Y. Okay, so this is a way of protecting our coordinates within the class. This is a way of accessing the coordinates from outside the class. We then have this little method here, and if you notice that CImageBase is the same name as class CImageBase, that essentially tells us that this is actually the constructor, and all constructors get called when you create or instantiate an object. Okay, so CImageBase is an object, it's a class. When it's instantiated, it then comes in here and it will call its constructor. Okay, and you'll see that we've got a parameter which we pass into the constructor, which is the bitmap itself. So when the constructor is called, what the constructor will do is to create a new bitmap type, okay, which is blank bitmap, but then it will pass in the resource, which will be our mol. So essentially creating a bitmap reference in memory of our mol, which we can then obviously access at a later date. Down here we have the draw image method, which we've created. This is a custom method that we've created, and this essentially just draws the mol on the screen, and the screen that we want to draw to will be the form itself, and we will be passing in a graphics object. Okay, and the graphics object, you'll see later on, is actually the form itself that we the background of the Windows form. We will be passing a handle to that form into this draw image, and then we will be calling a method on that graphics object, which is draw image, which is actually built into the system itself. And then three parameters that we need to pass into the draw image method is the bitmap handle itself, which we created here, you'll see, and the X and the Y coordinates, and that will then put our image on the screen. Okay, and dispose we've already covered. Okay, so without further ado, let's move on. The next thing we want to do is to create the mol class itself, which will be inheriting this base class. So again, back to mol shooter, add class, and this time we're going to be actually adding the mol class specifically. Okay, and again, to save a bit of typing time, we're going to paste in the code from the demo I created earlier and walk you through it. Now again, we can see that we've got some references that are missing, so select the word that's got the issue, drop down the flag and select using mol shooter properties, and now right for rectangle, click it, click the little flag using system drawing, and then that's fixed our problems. Save that so we don't have to go back and do that. And again, you will see we're actually inheriting from a base class. This time it's not the interface, this time it's actually our image base class, which we've just talked about. So this essentially means that this class, CMOL, has now access to all the properties and all the functions within this class. So you can see now how this idea of not duplicating the code works. It essentially means now that we can actually inherit this class in all our other image classes by putting colon and then the base class after colon after our class name. So that means that we can have a for example, CSign, CMOL, CSplat, C this, C that, colon, image base, and all of the methods in this base class will be made available to all our parent classes. Essentially means we don't have to keep typing draw image, draw image, draw image, image base, image base, image base. So you can see the benefits of that, I hope. And again in here we have the constructor. So CMOL constructor, and inside the constructor we set up the start coordinates for our image and the width and the height of our image. And we also, remember, here inside the constructor we pass in the mol bitmap. So in our parent class here we pass in the resource.mol. So this is how you actually access the resources inside the resources folder over here inside the solutions panel. So to prove that, if we come back over here to resources and press the period key, you'll notice now that you've got access to all the resources, and we've only got a couple in there. We've got the mol and we've got the background, and when we add the signs you'll see them in there as well. So this is how we get the resource out of or the image out of the resource folder. So we create a couple of properties here. So underscore mol hotspot.x. What the heck is mol hotspot, I hear you asking? Well, mol hotspot is simply a rectangle object which we create, which is contained within this here system drawing object, system drawing library, and it's a way that we can just keep and monitor and maintain the upper left coordinate of the mol and the size of the mol. We've declared it down here, which really isn't good practice. I don't think really needs to be up here at the top of the class. So mol hotspot, and inside the mol hotspot, if you hover over the rectangle, it'll say stores a set of 4 integers that represent the location and size of the rectangle. That's all it does. Essentially it means that we can pass the rectangle property around as a singleton, as a single object, and not 4 properties, whereas normally we would end up having to pass x, y, width and height around. This obviously means we don't have to pass x, y, width and height around. We can just pass this single object around, and get access to x, y, width and height. I hope that's clear. Next method is the update method. Now this is a custom method created by us, and it essentially updates or is intended to update the current position of the mol. So what we'll do inside the main application is randomly create an x and a y location, which will essentially put the mol at some random point on the screen. What we then do is we assign the x and the y location to the left and the top locations. Now left and top, remember, are in our base class down here. Left, top, so they're properties within the base class. So that's setting the top left coordinate of our mol. And then the mol hotspot x and the mol hotspot y is left plus 20 and top minus 1. Now that's a little bit confusing. What that essentially means is that the mol, if you remember, there we go, the mol, if you remember, has a background. Now this rectangle that you see here will appear on the screen as that, just as that, a rectangle. Now we removed this background, so you'll just see the hills and the sky behind that. However, when you click anywhere within this rectangle, you'll fire off around and potentially strike a hit. Now you obviously don't want to strike a hit when you click the background. You only want to strike a hit when you hit the mol himself. Again, you don't want to strike a hit when you hit the soil beneath the mol. So they're essentially dead shots. So the only part of the mol that you essentially want to score a hit on is the mol himself. So what we've done is we've created a region around this mole. Okay, so starting from the bottom left of the mole, going up to the top of his head and across to his right here, back down and back to the starting point, we've created a region, and we've called that the rectangle. So when we go back to our code here, okay, or I'll say we've called it the rectangle. It's a rectangle, but we've called it rectangle object, but we've called it mole hotspot. And hotspot being the point that you have to click into in order to score a hit. Okay, and what we've done is we've said that the left point of our hotspot is the left hand side of the mole plus 20 pixels. Okay, so it's essentially saying that the gap or the space between the left side of the image here and his ear roll is 20 pixels, and the same again for the bottom. So we've gone from the bottom of the image up to the bottom of the mole. Here we've gone top, sorry, the Y point of the hotspot is top of the mole down by 1. Okay, so that's created a rectangle within inside the mole as described. So that means now, obviously, to score a hit, you need to click anywhere within that rectangle. And the next thing is this method here, which is the hit detection method, which again is another custom method that we've created ourselves. And essentially you pass in the mouse X and the mouse Y coordinates. It does a little calculation, and if you're inside the hotspot it will return true, and if you're not inside the hotspot it will return false. Okay, so this line, what's this line all about? Rectangle equals new rectangle XY 1 1. So this is just creating a rectangle. The XY coordinates, i.e. at the mouse coordinates on the screen that you've passed into the function, and it's created a rectangle which is 1 pixel wide and 1 pixel high. Okay, we put here a little comment which says creates a cursor rectangle, which is a quick way to check for a hit. Okay, now the way we do this is that the mole himself is a rectangle, or the hotspot, as you can see up here, remember we just discussed, is a rectangle. And now we have another rectangle, which is the cursor rectangle, which we've just created here. And essentially what we're doing is we're checking to see whether the mole hotspot contains the cursor hotspot. So that's a built-in feature of C# and .NET. So by using two rectangles, you can check to see whether one contains another or one intersects another. So it's a great way for doing hit detection. So very simple, as you can see, simple one-liner. And essentially, if the hotspot does contain C, then we return a true. If it doesn't, we return a false. And that's the way we ascertain as to whether we've got a hit or not. So as far as our mole class goes, that's it. Okay, so the next task is to stick our mole on the screen. And to do that, we get rid of the mole class, save it, yes. Image base, save that, yes. Program, get rid of that. And form design, we can get rid of that for now, so that we're just playing around with the main form class, where we're going to now create the, or this is the parent class of the whole application, where we're actually going to create and maintain the update and game loop to draw the mole on the screen. So first things first, up here we'll create our, in fact let's not put it there, let's put it below the debug code. Here we need to create the C mole object, and what do we call him? Mole semicolon. And we are going to initialize this mole with inside the constructor. Okay, so mole shooter constructor is down here. So underscore mole equals new mole, and then what we do is we pass in the left hand side of the mole and the top of the mole. So this is going to place our mole on the top left hand side of the hill. If you notice, the Y coordinate is 200 and not 10. If you were to put 10 in here, you would actually draw the mole in the sky, and we don't want to do that. So as described earlier on in I think it was lesson 2, when we talked about our X and Y coordinates of the mouse and ascertaining as to where we are going to place our objects. Remember, we moved the cursor up and down, and we looked at the tops of the hills, and we worked out exactly what pixel location the top of the hill started at. So using those values, we've decided that we're going to draw the mouse at the left hand, 10 pixels in from the left hand side of the screen and 200 down, and that should place him on the top left hand side of our hill. Okay, so for now, we're not going to put in the hop code that causes the guy to hop all over the screen. We just really want to put the guy on the screen himself. We called him Michael, so we may as well refer to him as Michael the mole. So we basically want to stick the poor little chap on the screen. So we're going to do that inside of our on paint section here. And to do that, we reference our mole object underscore mole. Remember, we've created the custom draw image method inside of our mole class. We'll pop him up again. Look, well, you can see here we don't actually have a draw mole. That's because it's in our base class. Look, okay, where we get draw image, and we pass in the graphics object handle. Okay, so up here, draw image, and there's the device. DC actually stands for device context, which is the actual graphics object of the screen, which we will be painting on. Now you can see why we created the base class, because essentially when we create our signs, etc., as discussed, we can now just go sign.drawImage or mold.drawImage or splat.drawImage, and it will create and it will call the drawImage method on each of those 4 objects. So we've only got one instance of the drawImage created, i.e. one instance of the code. So it keeps the package, keeps the code or the application relatively light. So hopefully, fingers crossed, we can run this and puts our mole on the screen, as you can see. Wunderbar. However, clearly there's a problem, which is the size of this poor chap. So there's 2 ways you can do this now. One is you can scale him within the code, or you can put him back into Photoshop and you can reduce him. So let's do that. Stop the application. Okay, so within Photoshop, we'll just open up our friend, the mole 2. We know we've got the right one because he's got transparent background. We go to image size, and we want to change this guy down to around about, I think, 75 pixels wide and 56 pixels high. That's roughly the size of the mole in the original demonstration. Click OK. Then we'll save him again. File save. Let's rerun the application. And there you go. One happy smiling mole, Michael the mole. So I think that's enough for this lesson. In our next lesson, I think we will draw the signs on the screen. We'll just basically be reproducing a lot of what we've already done with some renaming. Putting graphics on the screen is no different now to the way we put the mole on the screen. Okay, so we've obviously got the sign to put on the screen here, which is our hotspot sign, so we can start and stop the game. Let me bring over the original application. Here we go. So in the next lesson, we're going to be creating this sign here with the hotspots start, stop, reset, and quit. So we can start the game, stop the game, reset it, and quit. So yeah, I hope you enjoyed this video. If you have any questions, or if it wasn't clear, or if I spoke too fast, or whatever, give me some feedback, and I'll see what I can do to improve or better the videos next time around. And hopefully I look forward to seeing you then. Take care for now. Bye bye.